Hey, my name is Junhua. This is my final project for NLP. So my topic is about the implementation of the knowledge extraction from the wiki. So this web page is the detail of the project. My task is to extract the knowledge from the wiki and choose a relationship such as the person, maybe person X is a member of group Y, even X happened before even Y. So this assignment provides 60,000 wiki articles. So I just download all the articles into my local disk here. So what I need to do is to save all of the files into my local database. Here I was using the MongoDB. So I think the most difficult of this part of the project is the wiki data. Yeah, because the data is very huge and the wiki data is growing every day, and the article is not well structured, so there are a lot of dirty date or tag in the article, such as a lot of HTML tag. So I need to remove all the tags. So and the wiki markup is hard to freeze. So what I did is to save all the here is the MongoDB database. I just save all the articles into the MongoDB database. In MongoDB database, there are one table in the database named article. The table have three fields: the name of the article, the content of the article, and the categories that the article belongs to. So here is the example date of the table. The name is the 20th hijacker, and the content is the content of the article, and the categories is the categories I have extract from the content. Example such as here, this the 20th hijacker belongs to two kind of categories. One is the September 11 attacks, and another is hijackers. Another line later is the same as the first. So I just save all the data to the MongoDB database. The next step, I need to train the classify. So here, I'm going to use the naive-Bayes algorithm to train the classifier. It is a simple probabilistic classifier based on the applying Bayes series with strong independence assumptions between the few features. Why I choose this kind of naive basis? Because this kind of extract knowledge from the wiki, all of the we can think of the words as the features, and between all the features, they are all independent. Yes, so it is perfect. This kind of algorithm is perfect for for the extraction. The following picture is the flowchart, what I have done in the code. So first of all, we need to determine the features here. As I said before, we choose the words as the features. And the next step, we need to get trade sample. So here, because I have stored all the articles into the MongoDB, so it will be very easy to fetch the articles from the MongoDB. So we can get training samples from the MongoDB. Next, we can calculate the possibility for error classified. Next step, we need to calculate conditions probability of every feature for all classes. So next step, we need to calculate the probability for error classes, and finally, we should pick the max the probability of the class. So here is the formula I'm using. Okay, here is the testing. The input is the training categories. I'm going to training is the categories is the other Apple in comparison employees and Microsoft employees and Google employees. Another is the cities in Illinois. The text name is Bill Gates, Steve Jobs, AI growth, and Chicago and Springfield, Illinois. So the red text is the result of the application. Here, the first Bill Gates, they have two possibility of the categories. One is he maybe belongs to Google employees, and maybe belong to Microsoft employees. As we can see, the possibility of the Microsoft employees is bigger than Google employees. So the next one, Steve Jobs, is maybe Google employees and maybe the Apple employees. So here, next one, maybe the Google employees. Chicago, we can see all the probability is 0 except the cities in Illinois. Springfield, Illinois, the Google employees. So maybe we can show you the code I have adjusted. Right. So this is the 4 categories I'm training, and here is the text list. I'm going to predict. So let's try to run. Okay, a little slow because we need to search the MongoDB, get the data from the MongoDB. So here is the result. here. First line is the Bill Gates, Microsoft employee. Yes. So I have improved the algorithm. I just smooth the algorithm. So maybe here it is a little different from what I have write in the write up in the for the possibility, I just normalize the probability to make it is can read. Okay, here is the Steve Jobs. Yes, app. Yeah. And here is the Chicago city in the Illinois, and the Springfield, Illinois city in the Illinois. Yes. Okay, so I have noticed that my implementation of the naive base is not very accurate because I think there are two aspects I need to improve. One is the date freezing, because there are a lot of dirty tag or something else in the articles. So I need to find to a proper way and the right way to freeze the date. I think it's difficult because different articles have different structure of the so I don't know, maybe there is a better way to freeze all the dates and remove the meaningless words in the articles. So the other aspect I need to improve is I need to optimize the classify algorithm. So something, so I think a lot of things I need to improve, but I think this is a good. So this is a good classified training algorithm.